My name is Adina Lee. I am the business lead for the 2015 project cycle. The University of Michigan Solar Car team designs, builds, and races the world's fastest solar vehicles. We start from scratch every 2 years, and the following year we compete in the American Solar Challenge with the same vehicle typically. The World Solar Challenge is a 3,000-kilometer race across the Australian outback from Darwin to Adelaide, the top part of the continent, all the way down to the southern tip. The race takes place over the course of 4 to 5 days in which the team races on highways and open roads with our solar-powered vehicle and our caravan. One of the main challenges we face is keeping a project together on a timeline that depends on so many different factors. Through the usage of Altair software, we were able to lightweight our design significantly, from our wheel to our composites roll cage, as well as increase the strength to be able to say that we've come up with the most efficient design possible that will help us win the race.
My name is Aurum, and I'm both the engineering director and the crew chief for the team. One of the big technical challenges this year was making our car as thin as possible. And the reason for this is making it thinner makes us more aerodynamic. We went into Altair's OptiStruct and we figured out what's our possible orientations. We went to our manufacturers and said, what carbon fiber can you supply us with what stiffness? Once we found that out, we were able to optimize our ply structure within our chassis and meet our stiffness requirements with a significantly thinner chassis than before. What we really like about OptiStruct is it really gives us the full range and freedom to do what we want to do in our analysis software, especially when it comes to the optimization side of the software. We can pick how we want to do it, our stiffness targets, how much weight we actually want to take out, and really culminate our requirements really well into our final product. And we know we can implement those at each step of the way very freely and very easily. One component that we optimized using OptiStruct was our rear suspension trailing arm. So before, our part weighed about 1.5 pounds in total. So what we did was we went back and re-optimized that, not to just be a solid metal component, but to be a combo of a metal component and a composite component. So the middle part we optimized using OptiStruct and reduced the weight from 1.5 pounds down to a single pound. And then on the outsides, we analyzed and added thin carbon sheets. All of this totaled up to a part that weighed 1.2 pounds, but had the same stiffness of the old part and was fully sealed and more aerodynamic. For some of us, we started working on this, and it's almost been 2 years we've been working on this single project of building Aurum. We've gone through our initial concepts, then designing it, then optimizing it, then building it, testing it, and going through all those steps. And now we're finally ready to go to Australia and win the World Solar Challenge and fulfill all the work that we put in all this time.